Hi, hello, hello. Today we shall be developing developing GARCH GARCH 1 model, meaning that there is one arch term, right? There is one arch term and one GARCH term, and that is called GARCH 1 model. And here we have first model is the mean model, right? And our model is something like this. BBR is C1 and C2 BSRE, and that is 1.1, right? And here, what is BBR? Bangladesh bond return. And what is C? The constant of the model. And what is BSR? Bangladesh stock return. And what is E? Residual, right? So that is our mean model, and that is 1.1. And here we have taken daily data of return of return return of 200 days. Okay, now the question is that when we should run arch and GARCH model. That is the question, right? Under what condition we can run arch and GARCH model? So the answer is there should have two preconditions before estimating arch and GARCH model, and they are: number one is the clustering volatility in the residual, and number two, arch effect in the residual. And only then we can run the arch and GARCH model. And what is called clustering volatility? It means that when the periods of high volatility are followed by periods of high volatility, and periods of low volatility tend to be followed by periods of low volatility for a prolonged period. And this behavior is known as clustering volatility. And this suggests that residual or error term is conditionally heteroscedastic, and it can be represented by arch and GARCH model. Okay, that is that is the precondition number one, and precondition number two is arch effect. And here, what is the null hypothesis? There is no arch effect. And what is alternative hypothesis? There is arch effect. And here, if I can reject null hypothesis and accept alternative hypothesis, in that case I can run the arch and GARCH model. So meaning that when our mean model, that is 1.1, has clustering volatility and also has arch effect, only then we can run the arch and GARCH model. And I shall check it very soon whether our model 1.1 has clustering volatility and arch effect or not. Okay, and we have one more model that is called variance model, right? The variance equation, right? And that is this one: HT C3 C4 is the coefficient of ht minus 1. C5 is the coefficient of e square t minus 1 plus IBR plus PBR, and that is 1.2, and that is variance model. Actually, GARCH model has two parts. One is mean model and one is variance model. Okay, and residual derived from mean equation 1.1 is used in making variance equation 1.2. Okay, and here what is a HT? What is HT? HT is the variance of the residual derived from equation 1.1. It is also known as current day's variance or current day's volatility of Bangladesh bond return. And what is C3 is the constant of the model. And what is HT minus 1? Previous day's residual variance or previous day's volatility of Bangladesh bond return, and it is known as GARCH term, meaning that this HT minus 1 is a GARCH term. Okay, and what is E square T minus 1? That is previous period squared residual derived from equation 1.1, and it is also known as previous day's bond return information about the volatility of Bangladesh bond return, and it is arch term, meaning that this one is the arch term. And IBR, what is IBR? IBR is the Indian bond return, and it is an exogenous or predetermined variable. And what is PBR? Pakistan bond return. It is an exogenous or predetermined variable. So in our variance model, what is this one? Volatility of Bangladesh bond return, and this one is the previous day volatility of the Bangladesh bond return, and it is GARCH term, and this one is arch term. And what is it? This one is the previous day's bond return information about the volatility of Bangladesh bond return. So meaning that arch and GARCH, these two are the family shock or the internal shock that influence volatility of Bangladesh bond return. Okay, and IBR and PBR, they are actually outside shock, and that can influence the volatility of Bangladesh bond return. So that I have said here. Here IBR and PBR are also known as variance regressor, as they can also contribute in the volatility of the Bangladesh bond return in equation 1.2. And this model is a GARCH 1-on model, as it has one arch term and one GARCH term. In other words, it refers to first order arch term and first order GARCH term. And higher order GARCH, that is 2-3 model. What is 2-3? 2 means 2 arch term and 3 means 3 GARCH term can be appointed also, but many researchers prefer to use GARCH 1-1 model for modeling the volatility of bond return. And here we shall estimate mean equation 1.1 and variance equation 1.2 simultaneously. Okay, and here arch and GARCH are the internal shock or internal influence that is influencing BBR, and IBR and PBR are the international shock. International shock or influence on BBR. So that is the thing. So what is the objective of the study? This study aims to model the volatility of the Bangladesh bond return and factors affecting the volatility in the return of PBR. Okay, so first we see our data. What is our data? Our data is given here: observation, BSR, IBR, BBR, and PBR. So here is the observation of 200 days data. You can see the data of 200 days. Right? You can see the data of 200 days, right? Okay. So first I run the mean model 1.1, right? Okay, how to run? So I have to go to the statistics, right? Then I go to time series because this one is a time series model. Then I declare the data set to be time series data. I click it here. Okay. Then time variable is OBS, right? Observation for 200 days data. I press OK. So this is my so you see observation 200 days. Okay, now I can run the mean model 1.1. I click on the statistics, then I go to linear model, then linear regression model, then our dependent variable is BBR and independent variable is the BSR, right? So so that is our model, and I click OK. So this is our mean model, right? Mean model 1.1. Okay, and if this model has clustering volatility, and if this model has arch effect, only then we can run the arch and GARCH model. Okay, so, but first we have to find out the residual of this mean model. Okay, how to get the residual? That is the question, right? Okay, first I create the residual. How to create the residual? of this model, I go to statistics, I go to time series, time series, then I go to I go to just 1 minute. I think post estimation, no, I go here, post estimation, right? Then I go to prediction and residual. I select this one. Then the variable name, that is the name of the residual, I put it as a R. Then I select residual of the model. I select this one, right? I select this one. That is the residual of the mean model. I press OK. You can see the predict R residual has been created. Now I plot this residual, right? I plot it. How to plot it? I go to statistics to plot it. Then I go to time series. Then I go to graph. Then I go to line plot, right? I select line plot, and then I have to create it. I just create. Then here I select R, right? I select R, and what is R? Is the residual. Accept, and I press OK. So the whole thing is coming up. The plotting of R. Yes, it has come up. You can see from here. It is residual, right? And it is 200 days plotting of residual, right? 200 days. Okay, here you can see it is day 1 until day 40, right? So here you can see small volatility is followed by by periods of low volatility. That means low volatility is followed by the next period of low volatility for a prolonged period. That means 40 days. Again, from 40 days until you can say 100 days, right? Until this, about this, right? So you can see high volatility from here to here, right? From here to here, from here to here, that means 40 days until 100 days, high volatility is followed by periods of high volatility, right? For a prolonged period. That means one high volatility is causing another high volatility for a prolonged period. And you can see from here, suppose from here 110 days until 150 days, low volatility is followed by low volatility for a prolonged period. And again, from here to here, the period of high volatility is followed by period of high volatility. And when this thing happens, we call it clustering volatility, meaning that when the periods of high volatility are followed by periods of high volatility and periods of low volatility tend to be followed by periods of low volatility for a prolonged period. This behavior is called clustering volatility. And when there is a clustering volatility, we can run the arch and GARCH model. Okay, and we can also check whether there is a arch effect or not. That we can check also from our model. Okay, and so this is our model, and we check whether there is a arch effect or not. How to check? I go to statistics as before, go to time series, then I go to post, no, not post estimation, I go to test, then time series specification test after regress. I select this one, then from here I select the arch, this one, test for arch effect in the residual, and specific the lag order. Suppose I put 1 as a lag of the arch test, right? Then I select OK. So this one is called LM test for arch, right? And this is the lag one, and the null hypothesis, there is no arch effect, right? That is the null hypothesis, and this is the chi-square value and corresponding probability. How much is the probability? The probability is 0.29%. From here you can see the probability is actually from here it is 0.29%, right? 0.29%, and which is less than 5%. So when the probability is less than 5%, then we can reject null hypothesis. That means I can reject this null hypothesis, meaning that our model has arch effect. So meaning that our mean model, that is 1.1, right, has clustering volatility, right, and also arch effect, right? So we have all the validity to run the arch and GARCH model, and that we shall do now. Okay. Okay, so how to develop the GARCH model? I go to statistics, time series, arch and GARCH model. I select this one, right? So it is coming up, and our dependent variable PBR and independent variable is BSR. So actually this one actually our mean model, right? That is model 1.1, and here the specify the maximum lags. Here our model is GARCH 1.1. So that so I put here 1, that is arch, and here I put also 1, that is GARCH. So meaning that, so this model is GARCH 1.1 model, because here is 1 arch term and 1 GARCH term. So this model is GARCH 1.1 model, and I select the model 2. I think here is nothing. Model 3, and we have two variable, and that is called conditional variance model. And we have two variable, that is one is IBR and one is PBR, and these two actually are the international shock, right? These are the international shock. And what is IBR? IBR is the Indian bond return, and PBR is the Pakistan bond return. And here you can see there are three distribution: Gaussian, student, and GED are here. So first I choose the Gaussian matter, Gaussian distribution. Then gradually I shall check student, and then I shall check this GED distribution. So first I select Gaussian, then I proceed, right? Okay, so my model is set completely. Then I can press select OK to run the model. Everything is set. Yeah, so she is going to estimate. So I think she needs some time. Iteration is going on. Okay, but eventually she can do it. Yes, she has been able to done. Finally, you can see that is the arch family model, right? Multiplicative heteroscedasticity. That is our GARCH model, right? And the GARCH model has two parts. One is mean model, that is 1.1, and the variance model. So from here you can see this first part is the mean model, the first part, right? And the second part from here to here actually the variance model, right? Variance model from here to here. Okay, and actually we want to talk about this variance model actually, right? Not about mean model. So actually we shall concentrate here the variance model, right? And here actually BBR is the dependent variable, right? And what is a HET? Actually this one is the volatility of Bangladesh bond return, right? That is the dependent variable. That is variance model 1.2 that I showed you last time, right? And this HET is the variance of the volatility. That means HET is the volatility of the Bangladesh bond return. Okay, so first I check whether IBR is it significant to explain the volatility of Bangladesh bond return, right? Okay, here you can see from here you can see that this is the coefficient, this is standard error, and this is Z statistics, and this is p value. Okay, so here is the how much is the p value. You can see from here the probability value is 38%, which is more than 5%, meaning that IBR is not a significant variable to influence the volatility of Bangladesh bond return, right? That means what is IBR? IBR is the IBR is the Indian bond return cannot influence the volatility of Bangladesh bond return, right? I'm sorry, I cannot speak properly right now. Okay, but what about PBR, Pakistan bond return, right? PBR, is it significant to influence BBR? Is it significant to influence the volatility of BBR? I can check from here. Yes, because the p value is very small, less than 5%, meaning that Pakistan bond return, this variable can influence the volatility of BBR. Okay, then I check the arch effect, right? Okay, whether this arch is it significant? The p-value is 19.5%, meaning that arch is not a significant variable to explain the volatility of BBR, right? And what about the GARCH effect? Is it significant? No. Yes, it is significant, meaning that GARCH GARCH is a significant variable to explain the volatility of BBR, meaning that I can say in other way I'm sorry, the GARCH is significant, meaning that previous days volatility previous days volatility of BBR can influence the volatility of BBR, can influence the volatility of BBR, right? So that is our first model having under Gaussian distribution. Under Gaussian distribution. Okay. Okay, now we can check whether this model has serial correlation or not, and we want to check whether the residual is normally distributed or not. That we want to check about our first model, right? Okay. So, but we have to create the residual first, and only then we can test whether there is a serial correlation or not, or whether the residual is normally distributed or not. Okay, so I check so I have to go to statistics, go to time, I have to go to post estimation, prediction residuals, I select it, and here, okay, so the new variable name, so the first variable, first distribution is the Gaussian, so I put it GR, right? Gaussian residual, right? Gaussian residual, and I select this one. Residuals are predicted innovation, and and the variable name is GR, Gaussian residual, right? I select it, press OK. So here is the things, right? So the variable is the GR, the name of the residual is GR. Okay, now I check whether this GR has serial correlation or not. That I want to check. I go to statistics, then I go to time series, I go to graph, I go to autocorrelation, right, and partial autocorrelation, right. I check it, and the variable name is GR. The name of the residual is GR, right, and here I press OK, and we call it correlogram actually, right. Okay, so here are these are the lag, right. Here I have chosen 40 lag, right, and here is the Q statistics. You can see the Q statistics and corresponding probability. Q statistics and corresponding probability, right. And you can see the probability all are 0, right. You can see the probability, right, all are 0, all are 0, right. That is less than 5%, very small, right. And what is the null hypothesis here? Null is there is no serial correlation, right, in the residual. That is the null hypothesis. An alternative hypothesis, there is serial correlation, right, in the residual. And here you can see all the p-value are very small. So we can reject the null hypothesis and we can accept the alternative hypothesis, meaning that there is serial correlation in the residual and that is not desirable. So we cannot accept this model because this model has serial correlation. Okay, then we check whether the residual has is normally distributed or not. Okay, how to check it? I go to statistics, then I go to summary tables and distribution plot, then I go to Shapiro. Actually there are many ways to check it, but I check here Shapiro-Wilk test, right, test of normality. I select it and our variable is GR, that is our residual, right. Then I OK. So that is the Shapiro-Wilk test for normal data. And what is the null hypothesis here? Here is null hypothesis. Residuals are normally distributed. And alternative hypothesis, residuals are not normal, right? Okay, here you can see the statistics 0.56955 and probability is very small, less than 5%. So we can reject the null hypothesis and can accept the alternative hypothesis, meaning that residuals are not normal, and that is not desirable. And this model is not good because this model is suffering from serial correlation, and also the residuals are not normally distributed. So we are not happy about this model, right? We cannot accept the model. Okay, so that is our first model, right? That is under Gaussian. And what is happening? I'm telling just again, that is IBR. This variable is not a significant variable, but PBR is the significant variable to influence the volatility of BBR, because the probability value is very small, and here the arch effect is not significant because the p value is 19.5%. So it is not significant, meaning that meaning that previous days, it means that previous days Bangladesh bond return information uh, does not affect the volatility of BBR, right? So that is the decision of this model when the arch is not significant. Okay, but here the GARCH is significant because the p value is very small, meaning that previous days volatility of BBR can influence today's volatility of BBR, right? Because this one actually the volatility of today, right? So actually what is our dependent variable? The dependent variable is the volatility of today's Bangladesh bond return, right? That is the dependent variable, right? Okay, so here the GARCH is significant, meaning that I'm saying again, the GARCH is significant, meaning that previous days volatility of Bangladesh bond return can influence today's volatility of Bangladesh bond return, right? And I told you arch and GARCH are the internal effect, and IBR and PBR are the international effect on the volatility of Bangladesh bond return. Okay, now we check our second model, that is under, I go to statistics, I go to time series, arch and GARCH model. I select it, right? So I think it is as before. I keep it like this. I keep it like this, and I select model 3. So last time I select Gaussian, now I select student T, and here I select 10 degree of freedom, and everything remain unchanged, right? Everything remain unchanged. Student T and 10. I select OK. So my then new model is coming up gradually under student distributions. It is coming up, comes up. Okay, it has come up. Okay, here what is happening, you can see the same thing. I beard, is it significant? No, because the probability is 83.7%. But what about PBR? Is it significant to influence the volatility of Bangladesh of BBR? Yes, because the p-value is very small, right? Less than 5%. That means PBR can influence BBR, the volatility of BBR. And what about this arch effect? Is it significant? Yes, because the probability is 3.8%, meaning that previous days BBR information can influence today's volatility of BBR. And what about GARCH? Is it significant? Yes, because the p-value is 1.6%. It means that previous days volatility can influence the volatility of today's BBR, right? So okay, it is done. Okay, now we can check whether how is the model, as a model is good or bad, whether this model has serial correlation or not, whether this model whether the residual is normally distributed or not. That we can check as before, but we have to create the residual first. So I click on the statistics and I go to post estimation, prediction, residuals, right? Then okay, last time I take it GR. Now the variable name is student residual, SR, right? Student residual. So I select residual, I click OK. Okay, predict SR residual. Okay, so I go to statistics. Okay, first I check whether there is a serial correlation or not. I go to time series, right? I go to graph, then I go to autocorrelation and partial autocorrelations. Then here I select SR, right? SR I select, then press OK. So it is correlogram, right? And as before, you can see from here, as before, lag, Q statistics and probability value. and you can see all the probability value is less than 5%, right? You can see, meaning that we can reject the null hypothesis and can accept the alternative hypothesis, meaning that there is serial correlation in the residual, and that is not desirable. So we cannot accept the model because there is serial correlation. Okay, now we check our second test, whether the residual is normally distributed or not. I go to statistics, then linear, then I go to summary, then distribution plot, then I go to Shapiro-Wilk test, right? So as before, I click here and I select SR. So SR, that is our new residual, student residual. I select OK. Okay, here you can see the statistics and the probability value. So here, what is our null hypothesis? Our null is the residual is normally distributed, and what is alternative hypothesis? Residual is not normally distributed. And here our p-value is less than 5%, meaning that we can reject the null hypothesis and can accept the alternative hypothesis, meaning that the residual is not normally distributed, and that is not desirable because the residual should be normally distributed. Okay, this model is not good because this model has serial correlation in the residual, and also the residual is not normally distributed. So we are not happy about the model. Okay, then we have the third distribution, that is the third and final. I go to Arch and GARCH as before, right? And it is fine. That is a GARCH 1-on model. So I go to model 3. So this time I select GED, generalized error distribution. I select this one, and here I put the value 1.5, right? And I run the model. So this is my last model, right? It's coming up gradually. It's come up. Okay, the result has come up. Okay, the whole result has come up, you can see. So here IBR, so this one is not significant because p-value is 69%, but PBR this one is significant to explain the volatility of PBR, because p-value is very small, less than 5%. And here the arch is not significant because p-value is 16.3%, which is more than 5%, meaning that previous days PBR information cannot influence today's volatility of Bangladesh bond return, PBR, right? But GARCH is significant because p-value is 0.8%, meaning that previous days, meaning that just 1 minute. Previous days volatility can influence can influence uh, can influence today's volatility of BBR, right? So that is the decision of the model. Okay, now I check the how is the model. That means whether this model has serial correlation or not, whether the residual is normally distributed or not. So as before, I have to create the residual first. I go to statistics and I go to post estimations and prediction residual. I have to create residual. Then okay, this time I put it GEDR, right? GEDR, right? Get residual, right? And I select residual, right? That I select, I press OK. Okay, so the get residual has been created. Now as before, I go to statistics, time series, then I go to graph and autocorrelation, right? Then this time GEDR, right? I select GEDR and OK. The result is coming up gradually. So here you can see as before lag, Q statistics and probability value. Here you can see the p-value are all less than 5%, meaning that in the residual there is serial correlation. So we are not happy about the model. This model is not good. Okay, then we check about the our second test, statistics summary, plot distribution. As before, I select Shapiro-Wilk test of normality, and our residual is GEDR, right? I select OK. Okay, so this is the Shapiro-Wilk test. This is the statistics and p-value. P-value is less than 5%, meaning that the residual is not normally distributed. So we are not happy about the model. The model is not good because this model has serial correlation and the residuals are not normally distributed. And thank you very much for being with me for a while.